All right, so ready to dive into something we literally do every minute of every day,
Always.
breathing. We've got this physiology handout here from Dr. Rasha Eldeeb,
Okay.
and I think it's going to be super eye-opening, honestly.
Yeah.
Whether you're like, you know, studying for a biology test or just curious about how those lungs of yours work, or even if you just want like some really mind-blowing facts to drop at your next party,
Mm-hmm.
get ready. Some serious aha moments coming your way.
You know what? It's funny how we kind of take breathing for granted, but the science behind it, it's like mind-blowingly complex.
Totally. For example, did you know that there's air in your lungs that doesn't even like get used for oxygen exchange?
Oh, you mean dead space?
Yeah,
Yeah.
dead space. And it's kind of like, imagine like a hallway leading to a room full of balloons.
Ooh, that's a good analogy. The hallway, that's like your trachea and bronchi,
Right.
right? Just a passageway.
Right.
And the balloons, those are your alveoli. That's where all the action happens.
Uh,
And to be super precise, we're talking about anatomical dead space here. There's also physiological dead space,
oh, okay.
which can include alveoli that aren't, functioning the way they should.
Okay, so two types of dead space. Got it.
Yeah.
But here's what blew my mind. So, like, the composition of the air, it like, changes as it travels through our respiratory system.
Mhm.
Like, did you know that the air we exhale actually has more oxygen than the air in our alveoli?
It's kind of counterintuitive, right?
Yeah.
But it makes sense when you really think about it. The air we exhale, it's a mix, right? It's a mix of the air that's been, involved in gas exchange in the alveoli and the air that's just been kind of hanging out in the dead space.
So it's all about the mixing. This dead space thing, though, does it affect how much oxygen actually gets into our blood?
Absolutely. That's where we got to talk about pulmonary ventilation versus alveolar ventilation. So
Okay.
pulmonary ventilation, that's the total volume of air moving in and out each minute. But alveolar ventilation, that's the volume that actually reaches the alveoli, for gas exchange.
Okay, so deeper breaths equal more efficient oxygen intake.
Exactly. Think about it. If you're taking those rapid, shallow breaths,
Yeah.
you're moving a lot of air.
Right.
But most of it is just hanging out in that dead space.
Yeah.
Deep, slow breaths,
Right.
they allow a larger portion of the inhaled air to reach the alveoli where it can do its job.
So that's why when I get stressed out and I'm like
Yeah.
taking those shallow breaths, I feel even worse.
Yeah.
Not enough oxygen getting to my brain.
Totally.
Speaking of things that can make breathing difficult,
Yeah.
what keeps those tiny alveoli from, like, collapsing?
That's where surfactant comes in, the magic of surfactant.
Okay.
Imagine those alveoli as like soap bubbles.
Oh, yeah.
Without soap, they would just hefty collapse.
Right.
Surfactant, it's like this amazing soapy substance that reduces surface tension inside the alveoli,
Mm-hmm.
keeping them open and preventing them from sticking together.
So it's like a lubricant for our lungs.
Kind of. And this handout mentions Laplace's law.
Yeah. Laplace's law.
Essentially what it's telling us is that, the smaller the sphere,
Right.
like our tiny alveoli, the greater the pressure needed to keep it inflated.
Huh.
Without surfactant, the pressure needed to keep those alveoli open would be enormous. Surfactant makes our breathing so much easier, especially when we exhale.
So those little alveoli, they have their own personal bouncers, keeping things in order.
I like that. And not only that, but surfactant also helps prevent pulmonary edema.
Which is?
It's a buildup of fluid in the lungs.
Gotcha.
Too much surface tension would make those alveoli like soggy and difficult to inflate. Surfactant keeps them dry and ready for action.
Surfactant is clearly the MVP of the respiratory system.
Mm.
But what happens if someone doesn't have enough surfactant?
Well, that's when things can get serious, especially for, premature babies.
Oh, right.
They can develop something called hyaline membrane disease, where basically their lungs haven't had enough time to produce enough surfactant.
Yeah, that's right. I remember reading about that. It sounds really scary.
It is.
Huh?
Thankfully, we can give them surfactant replacement therapy to help them breathe until their lungs catch up. And, it turns out that two hormones, cortisol and thyroxine, they're essential for surfactant production.
Wow, it's amazing how everything's connected in the body. Hormones, breathing, it's all linked. Speaking of interconnectedness, the handout also mentions pulmonary compliance.
Yes.
Is that like how stretchy our lungs are?
You got it. Pulmonary compliance, it's all about how easily your lungs expand and contract.
Okay.
Think of it this way, high compliance. Your lungs are stretchy, like yoga pants, and low compliance, they're stiff, like maybe those jeans you've had for a few years.
I love that analogy.
So the stretchier, the better. Well, not always. Too much stretch can be a problem, just like wearing out those yoga pants.
Right.
The data in this handout shows how lung compliance actually changes during inhalation and exhalation. It's a phenomenon called hysteresis.
Hysteresis sounds complicated.
It's a fancy way of saying that, the lungs are a bit stiffer during exhalation than inhalation.
Right.
And you guessed it, surfactant plays a role in that too.
Of course, surfactant, always the overachiever.
Yeah.
But the handout also mentions some things that can, kind of mess with lung compliance.
Oh, yeah.
Like fibrosis and edema.
Right, and those conditions can make the lungs stiffer, which decreases compliance, but there are also things that can increase compliance.
Oh,
like emphysema and even aging. And, it's not just the lungs themselves that have compliance. The chest wall does too.
really?
Things like obesity or, skeletal muscle disease can make the chest wall less flexible, making it harder to breathe.
Wow, so many factors at play. And it seems like there's this, delicate balance that our bodies are constantly trying to maintain. This is all so fascinating, but I think we need to take a breath ourselves, so to speak. When we come back, we'll dive deeper into the intricacies of surfactant and explore some of those factors that can affect lung compliance. Don't go anywhere.
Welcome back to our deep dive into the science of breathing. Before the break, we were talking about, how amazing surfactant is and, a bunch of different things that can impact how well our lungs stretch and contract.
Right. I'm still thinking about how surfactant seems to be involved in almost everything. It's like the WD-40 of the respiratory system. But this handout also mentions something called the lecithin-sphingomyelin ratio.
Right.
Or LS ratio. What's that all about?
Well, remember how we talked about surfactant being, especially crucial for premature babies?
Yeah.
The LS ratio is a way doctors can assess how mature a baby's lungs are even before they're born.
So like a sneak peek into lung development.
Exactly. So it involves analyzing the amniotic fluid, surrounding the baby. Lecithin, you see, is a major component of surfactant. As the fetal lungs develop, they produce more and more lecithin, while the level of another lipid, sphingomyelin, stays pretty constant.
So a higher LS ratio means more mature lungs and a better chance of breathing easily after birth.
You got it. If the ratio is low, it suggests the baby might need a little help breathing after they're born, potentially due to a lack of surfactant.
That's incredible. It's like a crystal ball for lung health. Okay, so we've covered dead space, surfactant, and lung compliance. But this handout also mentions some other things that can, throw a wrench in the works.
Yeah.
Like heart surgery. I wouldn't have thought those two were, connected at all.
It's fascinating, isn't it? So during heart surgery, sometimes, they use a machine that takes over the job of the heart and lungs for a while. But this can actually temporarily reduce blood flow to the lungs. Which affects surfactant production.
So it's like the cells that make surfactant are saying, hey, we need more oxygen here.
Exactly. It's a temporary effect, but it highlights how interconnected our systems really are. And there are other things that can impact surfactant, like, believe it or not, breathing in pure oxygen for too long.
Wait, wouldn't more oxygen be a good thing?
You'd think so, but inhaling super high concentrations of oxygen, for extended periods can actually create these things called free radicals, which can damage lung tissue and make it harder for the cells to make surfactant. It's all about balance,
Right. Makes sense. And of course, we can't talk about lung health without mentioning smoking.
Oh, absolutely. Smoking is like a one-way ticket to decrease surfactant production. It damages the lining of the lungs, messes with those surfactant-producing cells, and just, generally wreaks havoc on the whole respiratory system.
No wonder it's so bad for you. I'm noticing a trend here. It seems like anything that messes with blood flow or airflow to the lungs can, impact surfactant secretion.
You're picking up on the key point here. Even, blocking a pulmonary artery or a bronchus can throw things off. It's all about maintaining that delicate balance within the respiratory system.
Okay, keep those lungs happy and balanced. Got it. This whole deep dive has been a real eye-opener for me. I never realized how complex and, frankly, how fragile our respiratory system is.
It's truly remarkable. And speaking of remarkable, I think it's time we revisit this concept of alveolar interdependence. It's one of those things that once you understand it, you just can't help but marvel at the brilliance of the human body.
Alveolar interdependence. Yeah, that was the one where those tiny alveoli are all holding hands, right? like a microscopic support group.
Exactly. Those alveoli, they're all connected connected, so if one starts to collapse, its neighbors will pull on it, helping to keep it open, like a built-in safety net.
It's incredible how our bodies are designed to be so resilient. But this brings up a question that I think a lot of people might have. If our lungs are already so good at expanding and contracting, why is it so important to exercise and, focus on lung health? I mean, aren't they already doing their job?
That's a great question, and it's one that deserves some unpacking. Think of it this way. Your lungs are like any other muscle in your body. They benefit from regular workouts. Exercise helps strengthen the muscles we use to breathe,
Right.
making it easier to take those deep, satisfying breaths.
So it's not just about getting our heart rate up, it's about building lung strength, too.
Absolutely. Plus, exercise increases blood flow to the lungs, delivering more oxygen and nutrients to those hardworking cells. It's like giving them a little extra love and support.
Okay, exercise is good for our lungs.
Yeah.
Got it. But what about, like, air pollution or the elephant in the room, smoking? Can't those things undo all that hard work, even if we're exercising regularly?
That's the tough reality. Those tiny particles in pollution and the chemicals in cigarette smoke, they can really do a number on those delicate lung tissues, leading to, inflammation and damage over time.
So even with a healthy lifestyle, external factors can still pose a threat.
Unfortunately, yes. But being aware of those risks empowers us to make choices that protect our lungs. Like choosing cleaner air whenever possible. And, of course, steering clear of cigarettes.
That's a good reminder that we're not just these isolated systems. Everything's connected. And speaking of connections, I think we need to reconnect with our listeners after a quick break. We'll be back soon to wrap up this fascinating deep dive into the science of breathing. Don't go anywhere. Welcome back, everyone. I don't know about you, but I'm feeling a lot more aware of my own breathing after all this.
For sure.
It's amazing how much we discover, like, when we actually take a deep dive into something we usually just don't even think about.
Totally. It's like we've been holding our breath this whole time and finally let out a big exhale of, understanding.
Yeah. And speaking of exhaling, I think it's worth revisiting that whole thing about pulmonary ventilation versus alveolar ventilation.
Right, because it's not just about, breathing in and out.
Right,
It's about how much of that air is actually, doing the work.
Right, because it's not just about breathing in and out.
Exactly.
It's about how much that air is actually doing the work.
Yes. Pulmonary ventilation, that's the gross total.
Yeah.
All the air moving in and out each minute.
Right.
But alveolar ventilation, that's the net amount, the stuff that actually gets to the alveoli for gas exchange. Remember that dead space we talked about?
Oh, yeah, the hallway with the balloons.
Yeah.
I'm starting to feel like dead space is the real villain in this story.
In a way, it is. You could be breathing really fast, moving a lot of air. But if most of it's just going in and out of that dead space, you're not getting much oxygen to your blood.
So someone could be huffing and puffing, but still not getting enough oxygen.
Exactly. This handout has a really interesting example. It shows how someone taking, rapid, shallow breaths, let's say 30 breaths per minute, with a tiny tidal volume of 200 milliliters, could be moving the same amount of air as someone taking, slower, deeper breaths, say 10 breaths per minute, with a larger tidal volume of 600 milliliters.
So both scenarios have the same total air volume.
Right.
6 liters per minute?
6 liters per minute, yep. Same pulmonary ventilation. But the person with those deep, slow breaths, they would have way higher alveolar ventilation, meaning more of that air is actually, reaching their bloodstream.
So it's not just about how much air, but how effectively we use it.
Precisely. And this has major implications for, everything really, from, exercise performance to meditation techniques.
Right.
Learning to breathe deeply and efficiently can make a huge difference.
Wow. This deep dive has been a total game changer for me. I feel like I've been breathing wrong my whole life.
Well, maybe not wrong, but definitely with room for improvement, right? And that's the beauty of knowledge. It empowers us to make, informed choices about our health and well-being.
Totally. And speaking of empowering choices, I think this whole conversation has really highlighted how important it is to just take care of our respiratory system.
Yeah.
It's so much more complex than I ever realized.
Yeah.
And honestly, kind of vulnerable.
It's true. I mean, we've seen how everything from, smoking to heart surgery can impact our lungs' ability to function well. But the good news is there's a lot we can do to protect and support them.
Right. Like like being mindful of air quality, getting regular exercise,
Yeah.
and of course not smoking.
Exactly. And beyond those practical steps, there's also the power of like awareness, just paying attention to your breath, noticing its rhythm and depth. That can be incredibly grounding and calming.
It's like we have this built-in tool for like well-being,
Well,
and we forget to use it half the time.
it's true. But now that you've taken this deep dive into the science of breathing,
Right.
you have a whole new appreciation for its complexity and its power.
Absolutely. So as we wrap up this episode, I want to encourage everyone listening to just like take a deep conscious breath right now. Just like feel the air filling your lungs,
Yep.
feel that expansion in your chest,
Mhm.
and just appreciate like the incredible symphony of mechanisms that make it all possible.
Beautifully said. And remember, every breath is a gift, an opportunity to connect with your body, with your health, and with the amazing world around you.
What a perfect note to end on. This deep dive into the science of breathing has been truly eye-opening. I hope you've enjoyed it as much as I have, and that you'll take these insights with you as you continue to explore the wonders of your own body. Until next time, stay curious.